Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge A Level Mathematics 9709 Pure Mathematics P1. So, in this video, we will be solving May June 2024 paper 12. Okay, so let us get started. Okay, question number one is the coefficient of x square in the expansion of 1 minus 4x to the power of 6 is 12 times the expansion of x square in the expansion of 2 plus ax to the power of 5. Okay, so the coefficient of x square in the expansion of this is 12 times the coefficient of x square in the expansion of this expression. All right. So the question is find the value of the positive constant a. Okay, it says positive constant. That means that we might expect to have two values of a. Okay, either a could be positive and negative, or a could be 0 and positive. So we have to choose the positive value. Okay, so let us see. Now, the general formula that we have for binomial expansion is that NCR is equal to a to the power of r dot b to the power n minus r. Okay, or you can also write it as a to the power n minus r dot b to the power r. It's like convert is the same thing. Okay, all right. So sorry, this is not equal sign. This is NCR. Okay, and then you have dot a to the power r dot b to the power n minus r. So that's how we can work out the coefficient of any one of them, right? The coefficient of any power. So let us apply it over here. So we have 1 minus 4x to the power of 6. So for this, we are interested in finding the coefficient of x squared. So first of all, I'm going to write 6c, then I'm going to draw a bracket, two brackets, okay, one for each term. So this is for 1 and this is for minus 4x. Now, how can I set the powers in a way that I should get x squared? So that means I should write 2 over here, because when I expand this bracket, I'm going to get x squared. As for this one, the power over here is going to be 6 minus 2, which will be 4. Over here, I'm going to write the power 2. If you even write the power of 4, you'll actually get the same thing, because 6c2 is equal to 6c4. All right. So let us work this out. So 6c2 is 15. Then 1 to the power 4 is just 1. Then here you have minus 4x whole square. So this becomes 16x square. Okay. So when you multiply 15 times 16, let me grab my calculator. So 15 times 16, that gives us 240. So we would get 240 x square. Okay, that's the coefficient. So the coefficient of x square is 240. Now we need to find the coefficient of x square in the expansion of 2 plus ax to the power of 5. So for this case, the power that we have is n. The n is 5. 5c, and then I'm going to draw two brackets over here, one for each. So 2, and here we have ax. Now I need to set the powers in a way that I should get x squared. So again, I'm going to write 2 over here, and this time 5 minus 2 is going to give me 3. So the power over here will be 2 or 3, both can work. So 5c2 is going to give you 10. Then 10 times 2 to the power of 8. 2 to the power of 3, which gives you 8. So therefore you have 10 multiplied by 8, which is 80. So 80. Then from this side, we have a square x square. So 80 a square x square. Therefore, the coefficient of x square is going to be 80 a square. All right. Now, let's read the question again. It says that the coefficient of x square in the expansion of 1 minus 4x to the power 6, that means 240. That's what he's talking about. Is means equal. 12 times the coefficient of x square. What is the coefficient of x square for the second expansion? That is 80 a square. So that is the equation that we have formed, and this is what we're going to write over here. So 240 is equal to 12 times 80 a square. So we divide both sides by 12 and 80. So a square is equal to 240 divided by 12 times 80. So a square will be 240 divided by 12 times 80. That gives us 1 upon 4. Now I'm going to take square root both sides. So remember, when you take square root, you get two values, right? So therefore, a could be positive 1 upon 2 or a could be negative 1 upon 2. But because the question clearly tells you that we need to find the positive constant, so we'll say that since a is positive, therefore a will be 1 upon 2. Okay. Now, the question is that do you have to show this step? What if you, without showing that there's a negative sign, what if you directly write 1 upon 2? You might still get the same answer, right? So if you do not show this step, you might lose a method mark because you have to show the understanding that you're going to get two values. Based on what criteria are you going to choose one of the two values? That is this criteria, that since a is positive, the value of a is going to be half. Okay. All right. Let's move to question number 2. The curve y equals x squared is transformed to the curve y equals 4 times x minus 3 whole square minus 8. Describe fully a sequence of transformations that have been combined, making clear the order in which the transformations have been applied. Okay, first of all, just by looking at the graph, okay, or looking at the equation, this is y equals x squared, a simple quadratic curve, right? Within this function, how many transformations have been applied? So let us look. First of all, we will always consider what takes place inside the function. So inside the function, we have x minus 3. So this is horizontal translation by 3 units to the right. Okay, because remember, if it is a minus sign, we tend to take the opposite of that. Okay, so this is the first transformation that takes place. Let me write that down. Translation by. Okay, now there are two ways that you can describe it. You can either write the whole statement that that horizontal translation of 3 units to the right. You can do that, or you can just say translation by, and then you can write your answer in column vector form, because this column vector now tells you that you are translating by 3 units in x direction and 0 units in y direction. So it's only horizontal translation. Okay, so we have already studied this back in O levels or IGCSE mathematics, the how to describe the transformations. So you can write in this form as well. Number two, so after we have dealt with what happens inside the function, okay, so now we'll uh, look at what happens outside the function. Okay, the transformations that take place inside the function, those are horizontal transformations. The transformations that take place outside the function, these are vertical transformations. Okay, so let's see. Then what happens after you have converted this x square into x minus 3 whole square? The next step would be to multiply this by x minus 3 whole square. So multiplying this by 4, that is a stretch. Okay, a stretch along y-axis, or you can say that stretch in the direction of y-axis, or you can say parallel to y-axis. Okay, that's another word, parallel to y-axis, by stretch factor of 4. Okay, or you can just say by stretch factor equals to 4. That is the second transformation. Then we have a third transformation as well, which is the final one. Here we have subtracted 8. So now this is vertical translation. Okay, this is vertical translation, and because there's a negative sign over here, that means we are moving 8 units down. So we can simply say translation by 0 minus 8. That is it. If you want, you can write in this form, but if you want to explain in wordings, then you can say translation of 8 units down, okay, or you can say vertical translation of 8 units downwards. Okay, so that's what you can write as well. Okay, number 3, show that the equation 7 tan theta over cos theta plus 12 equals to 0 can be expressed as this equation. Okay, now from this equation that we have to so from our final equation we can see that everything is in terms of sign, so we have to manipulate our given expression, our given equation, in a way that there should be only sign ratio left. Okay, so first of all I'm going to use the identity that tan theta is equal to sine theta over cos theta. Okay, so I'm going to write here 7 times sine theta over cos theta divided by cos theta plus 12 equals to 0. Okay, then after that, or before we even do this, because this becomes a bit complicated, let me first get rid of this cos theta. So we will multiply both sides by cos theta, so we would be left with 7 tan theta. That this cos theta also multiplies with this 12, so we have 12 cos theta equals to 0. Okay, now we can write it in this form, that tan theta is sine theta over cos theta plus 12 cos theta equals to 0. Now what we can do here is we can write them in one fraction. So this is cos theta, this will be 7 theta as it is, but this one is now being multiplied with cos theta, so I can bring them into one fraction. So this becomes 12 cos squared theta equals to 0. Now, another identity that we have used, that we have studied, is sine squared theta plus cos squared theta is equal to 1. Now, whenever you are doing these type of questions where you have to prove the identities, okay, always write these identities at the side. You can write it in the center, okay, but because sometimes they don't give you enough space, so I prefer writing them at the end. Okay, so that way you might also get method marks even if you get this answer incorrect, because you've shown that what identity you're using. Okay, so make sure that you mention this in your working. Now I can multiply cos theta to the other side first of all, and at the same time, instead of cos squared theta I can write down, because if I make cos squared theta the subject, sine squared theta goes to the other side, so this becomes 1 minus sine squared theta equals to 0. So now we expand the bracket and we get 12 minus 12 sine squared theta equals to 0, uh, because the required form has positive 12 sine squared theta. I'm going to shift everything to the right hand side. So therefore this becomes 12 sine squared theta minus 7 sine theta minus 12 equals to 0. Okay. Then part B is hence solve the equation 7 tan theta over cos theta plus 12 equals to 0 for theta between 0 and 360 degrees. Make sure that your calculator is in degrees mode for this part. Okay. Now whenever you have to solve the equation, okay, just as a precautionary measure, what I usually suggest my students is that always verify, is this exactly the same as the equation which was given in the previous part, because sometimes, not always, sometimes they do manipulate a little bit. Okay, so you just need to be on safe side, right? So let's see, we have 7 tan theta over cos theta plus 12 equals to 0, and that is exactly the same. All right, so perfect, we can now use this equation. So we can say that 12 sine squared theta minus 7 sine theta minus 12 is equal to 0. So if you want to try to factorize this, okay, you might have to find the factors for 144. So that's quite a big number. So instead what I would suggest is you can directly use the quadratic formula. So sine theta will be equal to minus b, which is, so let me write this down. This is your A, this is your B, and this is your C. So what we can do is minus B, that means minus 7 plus minus B square. So that would be minus 7 square minus 4AC. Okay, let me write down the quadratic formula just in case. So minus B plus minus B square minus 4AC under root divided by 2A. So this is our quadratic formula. Then divided by 2 times A, which will be 12. Okay, and this should not be negative, and there should be a square root over here. Now, are you allowed to just directly now plug all of this in your calculator? No, you have to show one more step. Okay, so there will be one more intermediate step, which is 7. I'm going to write plus, just plus. Then I'm going to plug in this whole part, which is the square root of whole of this expression in my calculator. So 7 square minus 4 times 12 times 12. Okay, sorry, my bad. I thought that I was considering this one. So this was okay. This should be negative. All right, my bad. So therefore, we get 25 over 2 times 24. 22 times 12 is 24. So that is my first equation. The second equation will be sine theta equals 7 minus 25 over 24. So we'll work out each one of them. So 7 plus 25 is 32 divided by 24. So that will be 4 upon 3. And on the right hand side, we would have 7 minus 25 over 24, which is minus 3 upon 4. Okay. Now, if you take sine inverse of 4 upon 3, you will find out that there will be no solution. So you'll find math error. Okay. The reason is the maximum and the minimum value of sine theta is minus 1 and 1, because if I draw a sine curve, okay, very quickly, so you can see the maximum value that you can have for sine theta is 1 and the minimum value that you can have is minus 1, whereas this 4 upon 3 goes beyond 1, it is greater than 1, right? There is no value of theta for which you can have sine theta of 4 upon 3. You don't have anything over here, do you? Therefore, you won't have any solution. Anyhow, this is something that you should know, not for this particular type of question, but there are some questions where you are required to use this result. So you should know this. Okay. All right. For this one, I'm going to take sine inverse of negative 3 upon 4. So let's work this out. So we would get minus 48.590 degrees. Okay, now let us see. We are going to use the ASTC diagram. Here our given angle is minus 48.590. Okay, so we need to find the angles where we need to find that in which quadrant is sine theta is negative. So it is in the third quadrant and in the fourth quadrant. Because of the ASTC diagram, we know that in A, the first quadrant, all of them are positive. Second one, only sine is positive. Third one, only tan is positive. And in the fourth one, only cos is positive. So one of my results is going to be this one. I cannot use this result, which is minus 48.590. Why? Because the range is between 0 and 360, and this value, a negative angle, is going out of the range. Okay, so first of all, let me write the range over here. Theta is between 360 degrees and 0 degrees. Okay, so this will be my first solution. The second angle that we need to find is going to be this one. All right. Okay, now we know that this is 0, this is 90, and this is, sorry, 180, 270, and then finally 360. So this angle is 48, right? This angle is also 48. This is also 48.59. So what I'm going to do is, in order to find the green angle, okay, so theta is equal to 180 plus 48.590, and that gives us minus, sorry, not minus, 228.590. Okay. Then lastly, in order to find the blue angle, I can say theta is equal to, now this should be 360 degree minus 48.59. Okay, because this angle, like if you take a whole turn from this point to this point, that is 360 degree, but we are only going until this part, so that should be 360 minus 48.59. So 360 minus 48.590, and that would be 48.590, 311.41 degrees. Okay, finally, I'm going to write my answers, that theta is equal to, and my answer should be to one decimal place, 228.6 degrees and 311.4 degrees. Okay, that would be my final solution. So make sure that you give your answer at the end in this form, okay, where you have all the results and then just put them in a box or something. All right, that is the end of question number 3. Now let's move to question number 4. The function f is defined as follows. F of x is equal to root x minus 1 for x is greater than 1. So this is the domain of f. Okay, x is greater than 1. Find an expression for the inverse of x. Okay, now in order to find the inverse, the first step we can do is that instead of f of x, I'm going to write y equals to root x minus 1. Step 2 is you swap x and y. Okay, so instead of y, I'm going to write x. Instead of x, I'm going to write y. Okay, third step is to make y the subject of the formula. So minus 1 goes to the other side. So this becomes x plus 1 equals root y. Then I'm going to square both sides. So this becomes x plus 1 whole square equals to y. All right. So therefore, now in the last step, you're going to substitute y with the inverse function. So I'm going to write, therefore, f inverse of x is equal to x plus 1 whole square. So this is exactly the same technique that we used in O-level and IGCSE mathematics. Okay. There are also some different ways of doing it. Okay, but I prefer doing it this way. It's easier to understand. But if you have studied a different method, okay, so that's perfectly fine. All right, part B is, the diagram shows the graph of y equals to g of x, where g of x is 1 upon x squared plus 2 for x has all real values. Okay, so this is now the domain. State the range of g and explain whether the inverse of g exists. So there are two questions over here. First, you have to state the range of g. All right. Now, the range is the y values, right? So if I look at the graph, I can see that the graph is approaching closer and closer to x-axis, but it is not touching it, okay, on both sides. So that gives me an idea that there should be, or there could be, an asymptote over here, y equals to 0. So at x-axis, this is acting as an asymptote. An asymptote is a line to which a graph approaches closer and closer to, but it does not touch it. Okay. Secondly, I can see that the maximum value of y goes until this point, and at this point your x is 0. So if I plug in the value of x in this function, so if I say that g of 0 is equal to 1 upon 0 square plus 2, that gives us 1 upon 2. So that means this value over here, this is 1 upon 2. So this is the maximum value. The range is therefore going to be between these 2 points, between 0 and 1 upon 2. All right. Also, one more thing that we can look over here is that x can take any value up to infinity, because it says x belongs to all real values. So that means that we can take infinite values of x. So if I plug in infinity into my function, what does that mean? Infinity square plus 2. Okay, so infinity square, in look, infinity is not a number, it is a concept that we are considering a very large number. So if I take a square of infinity and then I add plus 2 into it, it will still be an infinity, right? It would still be an infinity. Now there's a result that you must remember. Okay, let me quickly list that down. 0 divided by any number is equal to 0. Okay, you have 0, and then in the denominator you have any number that is going to give you 0. That's result 1. Second result is any number divided by 0, that is going to give you infinity. We used to do this in the form of undefined, but now we are going to give it a concept called infinity. Okay, so this is what you get. If you plug this in your calculator, you'll get math error. All right, now based on what we found in 2, if I just switch them, if I make infinity the subject of the formula, that would mean that any, sorry, if I make 0 the subject, so any number divided by infinity is going to give you 0. Therefore if I divide 1 by infinity, I'm going to get 0 over here. So this tells you that 0, g of x equals to 0, this is your asymptote. Okay, so what will be my range? The range will be g of x is definitely less than or equal to half, and then we are going to write 0. But the question is, am I going to write here greater than, is 0 less than or less than or equal to? Because it cannot approach the value of 0, because over here we have an asymptote, then we are not going to write equal to. This is what my correct range is going to be. Okay, so let me write this over here. G of x equals to 0 is asymptote. Okay, hence this is exclusive in the range, so we are not including this value. Okay, so that is the first part of the question. So we have stated the range of g of x. Now the question is, explain whether g of x whether the inverse of g exists or not. What is the criteria to decide that whether an inverse of a function exists or not? So let me write this down. Inverse of g, okay, or in other words, g, okay, inverse of g exists if it's a one-to-one function. Okay, the inverse of a function can only exist if it is one-to-one function. Okay, so that is something what we have to look over here, that is it one-to-one function or not. So how are we going to draw the graph of an inverse function? Now you should know that the graph of an original function and an inverse function are actually reflection in the line y equals to x. So if I draw a grid over here and I draw a line, this is the line y equals to x. Suppose if I have a graph like this, okay, therefore the reflection, the inverse of this graph is going to be something like this. You get the idea? Now if I look over here, my graph is something like this, right? So this curve. Therefore the inverse function is going to be the reflection in this line. So you have to visualize it, that how is the graph going to look like. So it's going to look like something like this. Okay, if you flip it in, if you reflect it in the line y equals to x, this is what you're going to get. Okay, now how do we check whether a function is one-to-one or not? Okay, for that purpose we use something called the vertical line test. Okay, so we have to see that whether this is a function or not. Okay, so for this purpose, we are going to draw a vertical line through this graph, and you can see that as I draw a vertical line, there are 2 points where the graph cuts the where this line cuts the graph. So what does it tell you? It tells you that for one domain value you have two range values. So we can say the vertical line test shows that the inverse graph is one to many. Okay, why is it one too many? Because for one domain value, let's say this is your domain value x. For this domain value, you're getting y1 and you're getting y2. Okay, so a function cannot exist. This is not a function at all. This is a relationship between the variables x and y. So therefore, we will say that this is one to many, or you can also say that G inverse is not one to one, because we already established that what is the criteria for finding the inverse, right? So that's the end of this question. So I hope that this is clear. If let's say you are confused, then just rewind it, listen to explanation carefully again, and then you'll understand it. Okay. All right, the next part of the question is the function h is defined by h of x equals 1 over x squared plus 2 for x is greater than or equal to 0. Solve the equation h f of x equals f of 25 over 16. Okay, first of all, let me write down what is f of x from the previous part. It is root x minus 1. Okay, root x minus 1, and its domain was, this is greater than 1, was it? Yes. Okay, so now h of f of x means I'm going to substitute the function. I'm going to substitute the x value in your in this function by f of x. So therefore, 1 upon, I'm going to write this whole expression in place of x. So this will be root x minus 1 whole square plus 2. All right, so that is your h of f of x equals f of 25 over 16 means that now you're plugging in this value into this function. So that would be 25 over 16 minus 1. Now look carefully, this minus 1 is not part of the square root. It is outside square root. Okay. All right. Now, after this, we are going to write this. We'll just keep it the same way. Okay, for now. Whereas on the right hand side we have 5 upon 4 minus 1. Okay, so 5 upon 4 minus 1, that gives us 1 upon 4, and I still have root of x minus 1 whole square plus 2. Now why did I not take a negative sign over here? Because your domain value is greater than 1, so we have to take the positive side of it. All right, so we cannot take the negative solution. Now I'm going to cross multiply. So here we have 4 equals root of x minus 1 whole square plus 2. This 2 goes to the other side. So we have 4 minus 2, which is 2, root of x minus 1 whole square. Now I can take square root both sides. So this becomes 2, again plus minus equals root x minus 1. Since the domain is that x is greater than 1, again I'm going to consider only the positive value. So I'm going to write root 2 is equal to root x minus 1. You take 1 to the other side. So you have root x equals 1 plus root 2. Now in order to find x, I'm going to square both sides. So this will be x equals 1 plus square root of 2 whole square. Now what is the required form that he wants? So he wants in this form. So we have to expand it as well. Okay. So this means 1 plus root 2 multiplied by 1 plus root 2. So 1 times 1 is 1. 1 times root 2 is root 2. Root 2 multiplied by 1 is also root 2, and root 2 multiplied by root 2, that is going to give you just 2. So therefore x is equal to 1 plus 2 is 3, and root 2 plus root 2, that would be 2 root 2. Alright, that is going to be your final answer. Alright, question number 5. The first and second terms of an arithmetic progression are tan theta and sine theta respectively. So these are the first and second terms where theta is between 0 and pi upon 2. Now quickly you have to change your calculator in radians mode. Okay, so let me do that quickly. Okay, given that theta is equal to pi upon 4, find the exact sum of the first 40 terms of the progression. Okay, first of all, what is given to us is that the first term is tan theta, okay, and the second term is sine theta. All right, okay. So if I find out that what would be the exact value, so for theta is equal to pi upon 4, a will be tan pi upon 4. Okay, so this will be 10 10 pi upon 4, that would give you 1. And the second term is sine pi upon 4, that gives us root 2 upon 2. Okay, now in order to find the sum, we also need to find one more element in this formula, which is the common difference. So the common difference will be the second term minus the first term, so it would be root 2 upon 2 minus 1. So we'll just leave it in this form. Now the formula of sum is n upon 2 times 2a plus n minus 1 times d. So for the sum of 40 values, this would be 40 upon 2 times 2a, so a is just 1, plus 40 minus 1 times d. d is root 2 upon 2 minus 1, close the bracket. This becomes 20. Here we have 2 plus 39 times root 2 upon 2 minus 1. Okay, so let me calculate this first. So 39 times, or actually we have to leave in the exact form, right? So already it won't make sense if we try to calculate it. Okay, so now we can expand the bracket. So 20 times 2, that would be 40, plus 20 times 39. So 39 times 20, that is 780, times root 2 upon 2 minus 1. If I expand the bracket, so 780 times root 2 upon 2. So for that matter, this 2 and 780 will be simplified, and we get 390 root 2, and 780 times minus 1, that gives us minus 780. Now you can simplify it further. So therefore, my answer would be 390 root 2, and 40 minus 780 would be minus 740. So this is my exact answer. Okay. Now the next part is the first and second terms of a geometric progression are tan theta and sine theta respectively, where theta is between 0 and pi upon 2. Okay, so they have given you the same terms, but this time the question is about geometric progression. Okay, find the sum to infinity of the progression in terms of theta. All right, so what is the formula for sum to infinity? It is a upon 1 minus r. Okay, so let me write this down. A is tan theta, and the second term is sine theta. Okay, and because the question is in terms of theta, so we can leave our answer for A, it can be just tan theta, no problem. But the thing is, we do not know what is R. R is the common ratio, which is worked out by dividing the second term divided by the first term. So T2 over A So that would be sine theta over tan theta. Then using the identity, we can say that this is sine theta over cos theta. You can cancel the sine theta. So you'll be left with 1 upon 1 over cos theta, which becomes just cos theta. Therefore, the sum to infinity will be a, which is tan theta, over 1 minus cos theta. Okay, so that is your answer, because we cannot simplify it further as we do not know the value of theta. Now in part 2, given that theta is equal to pi upon 3, find the sum of the first 10 terms of the progression. Give your answer correct to 3 significant figures. Okay. Now, so what we're going to do here is, for theta equals pi upon 3, now a is going to be equal to 10 pi upon 3. Okay, that gives us root 3. And r is going to be equal to 10 pi upon 3 divided by 1 minus cos pi upon 3. Okay, so let's work this out. This is root 3 and cos pi over 3. So pi is 180, right? So 180 divided by 3, that's 60. So this would be half. 1 minus half. All right. And if I further simplify it, so let me work this out. Root 3 divided by 0.5, so that would just be 2 root 3, right? Okay, let me. Oh, okay, I see what I did wrong here. Sorry, my bad. R is actually just cos theta. Okay, uh, this is your R, right? R is equal to cos theta. So my bad. This should just be cos pi upon 3. Okay, and that would just give you 1 upon 2, which is 0.5. Okay, all right. Now, in order to use the formula for the sum of geometric progression, we have a times 1 minus r to the power n over 1 minus r. Okay, so that means the sum of first 10 terms can be worked out by plugging in the value of a, which is root 3, times 1 minus 0.5 to the power of 10 divided by 1 minus 0.5. So let us see. This becomes root 3 minus root 3 times 0.5 to the power 10, and this becomes 0.5. So if I plug in all of this in my calculator, I would get root 3 minus root 3 times 0.5 to the power of 10 over 0.5. So my answer would be 3.460718 dot dot dot. Now look, because the question is telling you to give your answer to 3 significant figures, first you have to show to a greater accuracy, and then you have to show that therefore my answer will be 3.4623SF. Okay, so whenever it asks you specifically, you have to show this, that you have to show at a greater accuracy, and then you show the rounding. Okay. All right, question number 6. The curve with equation y equals 2x minus 8x to the power of half has a minimum point at A and intersects the positive x-axis at B. Find the coordinates of A and B. So whenever you read the points, whenever you read the terms like minimum point, maximum point, turning point, stationary point, so all of these should give you a direction that this is a question related to differentiation. Okay, now it says find the coordinates of A and B. First of all, if there is a minimum point at point A, so what does that tell you? We know that at stationary points, whether they are minimum or maximum, your gradient function dy dx is equal to 0. All right. So first of all, we have to find what is our gradient function. What is my dy dx? So let me write down the equation. Y equals 2x minus 8x to the power of half. If I differentiate this, I would get, so this would be just 2 minus half multiplied by 8. So that would be 8 upon 2. Then you subtract 1 from the power. That would be 1 minus 1 upon 2. So I would be left with 2 minus 4x to the power minus 1 upon 2. Okay, so remember, how do you differentiate a function? You multiply the power with the coefficient and then you subtract 1 from the power. Okay, so this is my gradient function. Now we know that at A, okay, which is your minimum point, dy dx is equal to 0. So I'm going to equate this function to 0. So we have 2 minus 4x to the power minus half equals to 0. This 4x to the power minus half goes to the other side. So you have 4x to the power minus half equals to 2. 4 goes to the other side. Okay, what else we can do here is, we can also write this in this form. Okay, because I want to get rid of this negative power, so I'll take its reciprocal. Now x to the power half goes to that side and 2 comes to this side. So you'll be left with x to the power half equals, when 2 comes to this side, it will be 4 upon 2, which is 2. Now, one of the classic mistakes that students do at this point is that they take square root both sides, which is completely incorrect. If you want to get rid of this half, the power of half, you have to do the opposite of this. What is a power of half? The power of half is just a square root. So if I need to get rid of this square root, I have to square it, right? I have to square both sides. So after squaring both sides, what happens? We have x to the power of half whole square equals to 2 square. This 2 cancels with this 2, therefore x is equal to 4. This is the x coordinate of point A. Now that we have found the x coordinate, we will plug in this value into our original function, original equation, because this is now going to give me the value of y. So I'm going to write down that at x is equal to 4, y equals 2 times 4 minus 8 times 4 to the power of half. So here we have 8 minus 4 to the power half means that would be 2. Okay, square root of 4 is 2. Then this would be 8 minus 16, which will be minus 8. Therefore, A is at 4 comma minus 8. That's my first coordinate. Okay, the second coordinate that we have to find is of B. So let's read it again. It says that the curve with this equation has a minimum point at A, and the curve intersects the positive x-axis at B. At x-axis, y is equal to 0. So that will be our second equation that we have to start. So I'm going to say that at B, y equals to 0. Therefore, 2x minus 8x to the power half is equal to 0. This is the original equation of the curve, right? This one. Now, here what we can do is, we can take 2 and x to the power half as common. So I would be left with x to the power half minus 4 equals to 0. Okay, we can factorize 2 and x to the power of half. This 2 goes to that side, okay, and you'll be left with what? Two equations, that x to the power half is equal to 0 and x to the power half minus 4 is equal to 0. So this would be x equals 0, and this one would be x to the power half equals to 4. Again, here we are going to square root, we are going to square both sides. So this would be 1 upon 2 whole square, and 4 square. All right. So therefore, x is equal to 16. Therefore, b is at 16, 0. Now, why this cannot be the correct one? Because it says that b lies on the positive x-axis. Okay, so it cannot lie on the origin then. All right, so this is going to be my answer. Now, if you want, you can just make a circle over here and make a circle over here so that when your examiner is reading your script, okay, when he's reading the answers, he can clearly see that where are the final answers, okay. And if your final answers are already correct, it will be easier for him to give you the method marks right away. Obviously, he's going to check all your working, whether you have included all the steps or not, but it becomes a bit clearer, okay. Or if you don't want to make boxes over here, then your final answer in last two lines you must write something that therefore a is at what was the coordinate, 4 minus 8, and b is at 16 comma 0. Okay, the main idea is that after your long working, okay, you have to show your final answer in this form. Okay, just write it at the end. Okay, part b, the diagram shows the curve with equation y equals 2x minus 8x to the power half and the line AB. So this is the same equation that was in part A. It is given that the equation of AB is y equals 2x minus 32 upon 3. Find the area of the shaded region between the curve and the line. Okay, so this is your A. So that means the x coordinate of A is 4. The x coordinate of b was 16, right? That's what we found in our part A. So you need to, so these are the limits for our integration, because if I want to find the area under the graph, for that purpose we use integrations. This is a question related to integration with respect to x. Okay, now here you have two equations. So what we're going to do is, if let's say when I integrate this equation, okay, I'm going to get okay, let me first draw these lines so it's easier to explain. Okay, now when I integrate between the limits 4 and 16 for the blue one, I'm going to get the area which is all of this portion. Okay, everything which is above this curve. Okay, and when I'm going to integrate this function, the second equation, I'm going to get everything which is below this. So you see, starting from this point, so all of this. So you see, when I find both of their areas and if I subtract them, that would give me this required area. Get the idea? So that's how you have to first look at the bigger picture, okay, before you can start your working. So let us see. What I'm going to do here is I'm going to write down first of all y1 is equal to 2x minus 8x to the power of half. That's my first equation. And on right hand side, I'm going to write down my second equation, which is y2 equals, now this is written, this is obviously y equals mx plus c. So if I split this 3, okay, so I can write this equation as 2 over 3x minus 32 over 3. This is a bit easier because now we can integrate it term by term. Okay, all right, so let's first deal with the left hand side. I'm going to integrate this function between the limits b and a with respect to x. So that would mean integrating 2x minus 8x to the power of half dx, and the limits are 16 and 4. Okay, now what happens in integration? You add 1 to the power first of all. So originally the power is 1, so now the new power becomes 2, divide by the new power, okay, minus 8x to the power. Now we add 1 to the power and then we divide by the new power. So the new power is 1 upon 2 plus 1. Obviously, you don't have to do this. First, you can work out that what the new power becomes. So the new power becomes 3 upon 2. Okay, the new power becomes 3 upon 2. and therefore you divide this by 3 upon 2. Now there's going to be a change in notation. Okay, first of all, this is how we have to write down before integration. Then once we have integrated the function and we have limits as well, then I'm going to draw a square bracket and the limits will be written over here. So this tells you that now we have to plug in these values. All right. So, but before we can start plugging in the values, we have to simplify this first. So this 2 and 2 cancels out. So we have x squared over here. And this 2 multiplies with 8. So we have minus 16 over 3 x to the power 3 upon 2. Okay. Now we can start plugging in the values. Okay, so the first one is going to be 16 square minus 16 over 3 times 16 to the power 3 upon 2. That's the first bracket, minus 4 square minus 16 over 3, 4 to the power 3 upon 2. So we have to work this out. 16 square is 256. Then 16 upon 3 times 16 to the power 3 upon 2. So this whole part becomes 1024 over 3. In fact, you don't have to put the bracket now. So here we have minus, here we have to put the bracket because first we have to solve what's internally present, right? So 4 square is 16, and over here we have 16 upon 3 times 4 to the power 3 upon 2. So this one becomes 128 over 3. Now 256 minus 1024 over 3. This becomes minus 16, and minus times minus becomes plus 128 over 3. Now if I calculate this, so 256 minus 1024 upon 3 minus 16 plus 128 upon 3. So that gives me minus 176 upon 3. Okay, and it makes sense why are we getting negative, because the area that we are calculating is below the x-axis. So whenever you're calculating an area below the x-axis, it will always be negative. Okay, but once we have worked this out, we are going to only take the magnitude. So I'm going to say the area is equal to 176 over 3 without the negative sign. Okay, so that is the first part of this answer. Now I'm going to come on to the right hand side. Now we're going to integrate this function. So we have 2 over 3x minus 32 over 3. Okay, draw bracket over here. Then this is the integral sign, and we integrate between the limits 16 and 4. Got it? Now again, you add 1 to the power, so this becomes x squared, and then divide by the new power. So here we get 2x squared over 3 times 2. This 3 was already present, so now you're just dividing by the new power. Minus over here 32 over 3, this becomes just x because there was no x, right? So we are now introducing x over here. We draw a square bracket and we write the limits over here. Similarly, we can see that this 2 and this 2 cancels out, so you're left with 1 upon 3 x squared minus 32 over 3 x. So this is 16 and this is 4. Now we can plug in the values. So we can say 1 upon 3 times 16 square minus 32 over 3 times 16. Okay, there's also one more thing that you can do to simplify your working. You can take 1 upon 3 common. Okay, if I take 1 upon 3 common, so I can take it outside the bracket. So I would have x squared minus 32x. Okay, if this makes your life easier, then why not? So we have 1 upon 3 times, now x squared, that would be 6 square minus 32 times 16. Sorry, 16 square minus 32 times 16. minus the next bracket would be for 4. So here we have 4 square minus 32 times 4. Then we have 1 upon 3. Okay, do not forget that this 1 upon 3 is going to multiply by everything which is inside the bracket. Okay, so this is just one thing that you have to take care of. So 16 square is 256. Then 32 times 16 is 512 minus 4 square is 16 and 32 times 4 is 128. So 1 upon 3 times 256 minus 512. Now 16 minus 128. 16 minus 128 is minus 112, and when this minus multiplies, it becomes positive 112. Okay, now you can get the final answer. So 1 upon 3 is outside the bracket, and inside we have 256 minus 512 plus 112. So this becomes minus 48. Again, as expected, this would also be negative. So I'm going to say that the area will be 48. Now, 48 is going to be this area, which is under the straight line, under the line AB. Okay. As for this one, which is 176 upon 3, this is the area which is under the whole curve. Okay. So therefore, shaded region or shaded area is equal to 176 over 3 minus 48, and that gives us 32 upon 3. Okay, so this is going to be our final answer. There's another way of writing it. If you want, you can also write it in mixed form. Okay, so we can say 3 times 10. All right, so 10 2 upon 3, right? So 3 times 10 is 30. 30 plus 2, that is 32 upon 3. Okay, so you can also write it in the mixed form. All right, so let us move to question number 7. The equation of a circle is x minus 6 whole square plus y plus a whole square equals to 18. The line with equation y equals to 2a minus x is a tangent to the circle. Okay, so you have a circle and then you have this straight line which is a tangent. So what does that mean? That this line is going to cut the circle at one single point. Okay, so that means they could be, if we want to talk in terms of intersection points, that means there will be only one intersection point. Okay, find the two possible values of the constant a. Now, whenever we need to find intersection points, that is kind of saying that we are solving two simultaneous equations, right? So here, if I substitute 2a minus, sorry, if I substitute the y in this equation with this 2a minus x, that would give me whatever that works out to be, the x coordinate of that point will give me the intersection point over here. Let me repeat again, that if I substitute the y over here with 2a minus x, my whole equation is now in terms of x. If I can manage to find the value of x, that x coordinate will be the intersection point over here. Got it? All right, so let us first start with this. That will be our starting point. So x minus 6 whole square plus 2a minus x. So instead of y, I'm now writing 2a minus x plus a whole square equals to 18. Okay. Now, so here we are going to expand the bracket. So x minus 6 whole square, that means x square. Then x multiplies by minus 6 two times. So this would be minus 12x. Then minus 6 multiplied by minus 6, that would be 36. Okay. Plus here this becomes 3a minus x whole square equals to 18. Then we have x square minus 12x plus 36, then this becomes 3a whole square. So that would be 9a square. So if you want, you can expand it and then, so this is how we've worked out this part. And if I now expand 3a minus x, so we can see 3a times 3a, that would be 9a square. 3a times minus x, that would be minus 3ax. And then this minus x multiplied by 3a, again we have minus 3ax. Then minus x times minus x, that would be positive x squared. Now at the same time, we can also take this 18 to left hand side, so that I have all the terms on one side, and on the other side we have 0. Collect the like terms. So we have x squared plus x squared, so that becomes 2x squared. Then we have, okay, if I collect all the terms of x, so here we have minus 12x minus 3ax and minus 3ax, so that makes it minus 6ax. Then if we come to the constants, we have 36 and we have 18. So 36 minus 18 would be plus 18 equals to 0. Last step over here would be to take x common. Okay, so if I take x common, so I would be left with minus 12 minus 6a plus 18 equals to 0. Now you can see that this is a quadratic equation. All right. Now, if you look over here again, what does it tell you? What is this equation? If I solve this equation and if I solve this equation, what is the x coordinate going to give me? It will give me the x coordinate of intersection point, right? So at intersection point, there's only one root to this equation. So that means we can say, when once we have only one root to a certain equation, the discriminant is equal to 0. Okay, so this is a question which is related to circle as well as the discriminant. So b square, that would be minus 12 minus 6a whole square minus 4 times a, which will be 2, times c, which will be 18. Okay, now let us expand it. So minus 12 whole square, that would be 144, minus 12 times minus 6a, that would be positive 72. Double it, that would be 144a. Then again minus 6a whole square, that would be plus 36a square. Okay, now let's come to this part. Minus 4 times 2, that would be minus 8, and minus 8 times 18. Let me calculate that. So that would also be minus 144. Okay, my bad. I think I forgot to take into account 9a square. Let me just fix it quickly. So the constants, okay, this is another constant, right? We have 36 minus 18, that is also 18. And then you also have 9a square. So this is plus 9a square, right? So let me write it in this form. 9a square plus 18. So your constant is going to be 9a square plus 18. So that means that now what we are doing is minus 4 times 2 is minus 8. Minus 8 multiplied by 9a square is minus 72a square. And minus 8 multiplied by 18, that was minus 144 equals to 0. Okay, now this is fixed. Okay, so from here we can see that this 144 and this minus 144, they are cancelled. Then we have 36a square minus 72a square, so that would be minus 36a square plus 144a equals to 0. We can shift both of them to the right hand side, so this becomes positive, this becomes negative. I can factorize a, okay, as well as I have to see if 36 is divisible by 144? Hang on a minute. Yes, it is. So I can take 36a outside. I can factorize it. So I will be left with a minus 4 equals to 0. So that means that either a is equal to 0 or a is equal to 4. All right. If you want, you can write it in an extended way as well. 36a is equal to 0. Then here we write a minus 4 equals to 0. From here we can see a is 0, and from here we can see a equals to 4. Now what was the question? Why are we getting two values? So we have to find two possible values. This is our answer. That's it. If suppose the question would have extended and said that find the positive value of a, then we would have selected just a equals to 4. All right, that is the answer to this part of the question. Okay, the second part is, for the greater value of a, find the equation of the diameter which is perpendicular to the given tangent. Okay, for the greater value of a means that for a equals to 4. Okay, that's what we know. Find the equation of the diameter which is perpendicular to the given tangent. Okay, so if we have a tangent, something like this, then your diameter is going to be perpendicular. So that means it passes through the center, and it's going to be perpendicular to the tangent. All right. Okay, so first of all, let us find the equation of AB. Okay, this is your line AB. Okay, so let us see. At A is equal to 4, y is equal to, what was the equation of line? 2a minus x. So this would be 2 times 4 minus x. So that would be 8 minus x. Y equals to 8 minus x. If you want to rearrange it, you can also write it as in the form mx plus c. So that would be minus x plus 8. Okay. Now, what we can notice here is that if I want to find the equation of this diameter, okay, you need to find the equation of this blue line. This is your diameter. So you need to, okay, because this is also a straight line. So this is y equals mx plus c. You need to find the gradient. You need to find the y-intercept. Okay, so first of all, let us try to find the gradient. I cannot directly find the gradient of this straight line. However, because I know that this is perpendicular to AB, so whatever the gradient of AB is going to be, it will be the negative reciprocal of that. Okay, so from this equation we can see that the gradient of AB is minus 1. Okay, so the gradient of perpendicular is equal to negative reciprocal, means that you divide your gradient by minus 1. So this would be minus 1 over minus 1. That gives us just 1. Okay. So I think what's better is that instead of perpendicular, I can just say the gradient of diameter. Okay. Now, in your AS maths, you have studied that in coordinate geometry, that if you have the gradient and you have one coordinate, you can use this equation, y minus y1 times equals m times x minus x1. So you don't even have to know y-intercept. So if you do not know what is y-intercept, you can directly have a coordinate and have your gradient, then you can find out the equation as well. So that means I need to find a coordinate through which my diameter passes through, and we know that the diameter is going to pass through the center of the circle. So from the equation of circle, from equation of circle, which is x minus 6 whole square, okay, plus y plus a square. Okay, a was 4, right? So y plus 4 whole square y plus 4 whole square equals to 18. So that means from this, what can we find out? We can say that the center is at, now your general form of the equation of circle is this, okay, x minus a whole square plus y minus b whole square equals to r square. This is exactly in this form, so therefore the value of a, the your x coordinate of the center is going to be just 6. However, this one is different. The general form is that this should be minus b, so in order to bring it into this form, your value of b should be negative, so therefore this would be minus 4. Okay, such that if I plug in minus 4, this will give me plus 4, which is this one. So you get the idea. So this is the coordinate of the center of the circle. Now I can use the coordinate geometry concept. We can use this equation: y minus y1 equals m times x minus x1, y minus 6 equals, the gradient was just 1, and x minus 4. Okay, I think I did it the other way around. Your y coordinate is minus 4, right? So this should be y minus 4. So this becomes y plus 4. As for this one, this becomes minus 6. So here we have x minus 6 minus 4. Therefore, your equation will be x minus 10. Y equals to x minus 10 is the equation of the diameter. All right, let's move to question number 8. The diagram shows a symmetrical plate A, B, C, D, E, F. The line ABCD is straight and the length of BC is 2 centimeters. Okay, where's BC? This is your BC, and it says that ABCD, so this whole line, this is a straight line. All right. Each of the two sectors ABF and DCE, ABF and DCE, is of radius r centimeters, and each of the angles ABF and DCE is equal to pi upon 3 radians. Okay, so this is my center of this sector, this is my center of this sector. So this is r and this is r, this is r and this is r. Okay, it is given that r equals 0.4 centimeters. Show that the length EF is 2.4 centimeters. Okay, this is the length EF that you have to find out. Okay, so if you look over here, part of this length is something that we already know. Like if I draw a straight line over here, so we already know that this much is going to be 2 centimeters. So we just need to find the remaining part. Okay, okay, and also if you notice another thing over here, that this is Z, right? So that means that this is an alternate angle over here. So if this angle is pi upon 3, then that means this angle is also pi upon 3. Okay, and the same goes over here as well, that this angle is also pi upon 3. It tells you that this is a symmetrical plate. So whatever we have over here is going to be the same on the right hand side as well. So from here, what can we notice? Because I need to find this length, okay, let me mark a point over here. This is, let's say, point X. Okay, it'll be easier to address then. So let me draw this triangle BXF. So this is BXF. This is your 90-degree. BF is R, which is equal to 0.4 centimeters. Then the angle BFX, this one is pi upon 3. And we need to find Fx. So we can use trigonometry over here. I need to find Fx, which is my adjacent, and I have been given hypotenuse. So I can use cos. So we can say cos pi upon 3 is equal to adjacent, which is fx that we need to find, divided by 0.4. So therefore fx is equal to 0.4 times cos pi upon 3. 0.4 times cos pi upon 3 is 180 divided by 3, which is cos 60, right? In degrees. So that gives you half. So therefore this is 0.2 centimeters. Fx is 0.2 centimeters, and similarly this over here, let's say that this is I don't know, maybe we can say uh, t, for example. Okay, you can take any point. So let's say this te is also going to be 0.2. So now your total length of ef will be fx plus xt plus te. Okay, so fx is 0.2, xt is 2, which is over here, and te is also 0.2. So when you add all of them up, you will get 2.4 centimeters, and that is what we had to show. All right, the second part is find the area of the plate. Give your answer correct to three significant figures. Okay, so we need to find the area of the plate. So always look at the bigger picture. What can you see when once you look at the whole the whole symmetrical plate? So we can see that this figure is actually divided into three sections, right? You have this sector, then you have a second sector, definitely because they're identical, so they're going to have the same area, and then you're going to have this whole trapezium starting from this point. Okay, all of this. So in short, what I can write over here is that area of the plate is equal to area of two sectors plus area of trapezium. Okay, now we know that the area of sector is half r squared theta. When we are doing this in radians, the area of sector is half r squared theta. So this would be 2 multiplied by, because we are considering two sectors, so that would be 2 times half r squared theta plus the area of trapezium is half into sum of parallel sides multiplied by the distance between the parallel sides, which is h. 2 and 2 cancels out, so the radius is 0.4 square, and the theta was pi upon 3 plus half into, now the parallel sides would be, the first one is 2 centimeter, the second is 2.4 centimeters. So we have 2 plus 2.4, and the vertical height or the perpendicular distance between them, okay, that is going to be bx, which is unknown. Okay, we don't know what is bx yet. So if we can use the same triangle that we used above, okay, let me quickly redraw it. So this is b, x, and f. So this is pi upon 3, and this is 0.4 centimeter, right, r. This time, instead of fx, I need to find what is bx. So I need to find opposite, and I have hypotenuse, so we can use sine. Sine pi upon 3 is equal to bx over 0.4. So bx will be 0.4 times sine pi upon 3. This becomes 0.4, or maybe if you want, you can directly just write this over there. We can work it out on that side. So now this value is going to be plugged in over here. So 0.4 square times pi over 3. So let me work out 0.4 square divided by 3. Okay, so this would be 4 over 75 pi plus, then we have half into 2 plus 2.4. So that would be 4.4 divided by 2, which is 2.2. And bx is going to be 0.4 sine pi over 3. All right. Now you can plug all of this in your calculator, or maybe we can just do one more step before we do that. So 4 over 75 pi plus. Now 2.2 times 0.4 multiplied by sine pi upon 3. So that gives us root 3 upon 5. Now we can plug all of this in our calculator. So we have 4 upon 75 pi plus 2.2 times root 3 upon 5. So therefore the answer that I'm going to get will be 0. 0.92965 dot dot dot, and again because we have to give our answer in 3SF, now I'm going to write this as 0.930 centimeter square. All right, so that was the question related to circular measure. Then it says it is given instead that the perimeter of the plate is 6 centimeters. So it is given instead means that whatever information was given to you in part A of the question, including the fact that r is equal to 0.4, this is no longer applicable. Okay, so understand this carefully. Only this part of the question is applicable. Whatever we did in our part A, that is no longer applicable in part B. So now it says that it is given instead that the perimeter of the plate is 6 centimeter. Find the value of r, give your answer correct to three significant figures. So the perimeter, we have to see that what is going to be my perimeter. So let's look over here. The perimeter is going to be starting from point A. We have r plus 2 centimeters plus r plus the arc DE plus EX, or we can from here you can directly say EF, right? Um, no, actually we cannot, because this EF, again we do not know that this is 2.4. We cannot use this value. So we'll do ET, then we have TX, then TF, and then we have FA. Okay, so we have this whole situation going on. At least for just not to make a working complicated, I write it in this way, that starting from A, again we have R, then 2, then R, and then after that we had arc DE, was it? Yes, then we have arc DE, then I'll just write EF and then arc AF. Okay, so arc DE plus EF, and then we have arc AF. Okay, then this perimeter is equal to 6, which is given to you. So r plus r, that is 2r plus 2, plus arc DE would be r theta. Okay, so that means r times pi upon 3. Then we have plus EF. I'm just going to write this as it is for now. Plus arc AF, again this is going to be r times pi upon 3. Okay, so let's try to simplify what we have found. So I can subtract this 2 to the other side. So we have 6 minus 2. And on this side, we have 2r plus 2 over 3 pi. I can add both of these. So pi over 3r plus again pi over 3r. So we have 2 pi over 3r. And then we have plus EF. Okay. So this becomes 4. And over here, so let's see. Now EF is going to be, so EF is 2 centimeters plus these lengths that we have over here. Okay, so Fx and Et. So let's try to find Fx. Okay, so what I'm going to do here is that I'm going to say that 2r plus, in fact, what we can do also, okay, let's just write this for now. Okay, and then we'll combine later, because I was about to factorize it, but then even for EF we will still have the radius, right? So let us just keep it the same for now. EF is the sum of 2 centimeters plus FX plus uh, what was the other one? TE, okay, or ET. Okay, now let's try to find FX. Again, I'm going to draw this triangle, which is BX, and this is F. This angle is pi upon 3, okay, and this is your radius R, which is unknown. So we can find an expression in terms of R. So this expression would be cos pi over 3 equals to Fx upon R. So therefore Fx is equal to R cos pi upon 3, and cos pi upon 3 was half, right? So half R. Now we also know that TE is equal to Fx, so that is also equal to half R, because there again it is symmetrical, right? So this is also going to be half R. TE is half R and Fx is half R. Therefore EF, the whole length, is going to be 2 plus half R plus half R. So let me now write this down. 4 equals 2R plus 2 upon 3 pi R plus 2. Now instead of Fx, I'm going to write half R, and for TE again I'm going to write half R. So now this 2R plus half R plus half R, that makes a total of 3R plus 2 upon 3 pi R. Okay, now we can factorize R. So I would be left with 3 plus 2 upon 3 pi, and therefore um okay, my bad, this 2 was also there, right? So we can also subtract this 2. So let me first write this as 4 minus 2, because this 2 goes to the other side, so you have 4 minus 2, this becomes 2. So therefore R will be 2 upon 3 plus 2 upon 3 pi. Now we can work out the value. So we'll have 2 over 3 plus 2 upon 3 pi. That gives us 0.3925, 0.39258, and dot dot dot. Therefore, to 3SF, my answer would be 0.393 centimeters. All right, and that is the end of question number 8. Question number 9 is, a function f is such that f dash x is equal to 6 times 2x minus 3 whole square minus 6x for x belongs to all real values, or x has all real values. Determine the set of values of x for which f of x is decreasing. Now this is another type of question which is related to differentiation. So when your function is decreasing, then what you should know about it is that your derivative, your gradient function, is less than 0. For a decreasing function, your gradient is less than 0. That means it is negative, right? So I'm going to write this expression that is written over here, because this is already f prime x or f dash x. So 6 times 2x minus 3 whole square minus 6x is less than 0. Okay, I can factorize 6 outside. So this would be 2x minus 3 whole square minus x less than 0. Divide 6 both sides so that so you can just get rid of it. So I would be left with 2x minus 3 whole square minus x less than 0. Now here you have to expand this. Okay, you have to expand the bracket. So 2x minus 3, 2x minus 3. So 2x times 2x would be 4x squared. 2x minus 3 would be minus 6x. And then again minus 3 times 2x, that would be again minus 6x. So that would be minus 12x. And then minus 3 whole square, that means minus 3 times minus 3, that gives you positive 9. minus x less than 0. So 4x square minus 12x minus x, that makes it minus 13x plus 9 is less than 0. Now you have to factorize it. Okay, so 4 times 9 is 36. I need to find factors of 36 such that when I multiply them, I should get 36, and when I add them, I should get minus 13. So the factors of 36 would be 1 times 36, 2 times 18, then we have 3 times 12, 4 times 9. So 4 times 9 itself is going to be that particular pair. Okay. So what I can do is I can say minus 4 and minus 9. So this would be 4x square minus 4x minus 9x plus 9 is less than 0. You take 4x common, so we have x minus 1. Here we can take minus 9 common, so I'll have x minus 1 again. Then we have x minus 1 common, and what's left is 4x minus 9 less than 0. Now this is where we stop. Okay, here we are going to write this as x minus 1 times 4x minus 9 equals to 0. Why? Because we have to find the critical values. So here we have x is equal to 4, and here we have x is equal to 9 upon 4. So this is what we call the critical values. Now I'm going to draw the x-axis. Okay, we'll draw a sketch. So this is the question related to quadratics. Okay, so on left hand side we can have 1, and on the right hand side we have 9 upon 4. So my function is less than 0. Okay, at which part of the curve? So less than 0, y is going to be less than 0 between these two values. Okay, because this is x-axis, right? This line, this represents x-axis. So y is less than 0 means that y is below the x-axis, and it is below the x-axis between this region. So therefore I'm going to say that x is between 1 and 9 upon 4. Okay, so this is going to be my final answer. Then it says, given that f of 1 is equal to minus 1, find f of x. Now this is just one clever way of giving you the x and y coordinate, because f of x means that this is your x value, the output value is going to be your y value. So the question has already given you a coordinate. Okay, so the coordinate is going to be 1 minus 1. Why this coordinate is given here? Because it is going to help us in finding the constant of integration, the value of c. Because the question is asking you to find fx, and what's given to us is f dash x. So here we will be integrating it. So let us see. 6 times 2x minus 3 whole square. 6 times 2x minus 3 whole square minus 6x. Okay, now there are two ways that you can do this question. So I'll show you both of them, and then you can decide which one suits you best. The first method is where we expand the brackets. Okay, so I'm going to expand these brackets. So f dash x equals 6 times 2x minus 3 whole square. Okay, so this would be 4x square minus 12x plus 9. We already did this in the previous part. So this is what we get, and then we have minus 6x. 6 times 6 times 4, that would be 24x square minus 72x plus 54 minus 6x. 24x square minus 72x minus 6x, that would be minus 78x plus 54. This is my gradient function. Okay, now in order to find f of x, okay, so f of x will be you have to integrate this. Since there are no limits given here, this is an indefinite integral. So you have to integrate the function with respect to x. So this becomes 24. You add 1 to the power, so the new power is 3. Divide by the new power. Okay, again you add 1 to the power, so originally this is 1, so new power becomes 2. Divide by the new power, plus 54x plus c. Okay, simplify this. 24 upon 3, that would be 8x cubed, minus 78 upon 2 is 36, is it? 78 divided by 2, sorry, 39. 39x squared plus 54x plus c. So now in order to find this constant, okay, this is where we are going to use this coordinate that is given to us. So I'm going to write down that at 1 minus 1, that means minus 1 is equal to 8 times 1 cube minus 39 times 1 square plus 54 times 1 plus c. So minus 1 is equal to 8 minus 39 plus 54 plus c. So c is equal to, now what is 8 minus 39 plus 54? That is 23. So when this 23 goes to the other side, it becomes minus 23. So therefore c is equal to minus 24. Hence your f of x will be 8x cubed minus 39x squared plus 54x minus 24. This is going to be your final answer. Okay, this is method 1, where we have expanded our bracket, and what do we get? We get a cubic function, okay, a cubic equation. Method 2 is where we can use the chain rule, okay, using the chain rule. So let me write down what is f dash x. Originally it was 6 times 2x minus 3 whole square minus 6x. If I want to integrate this, if I want to find f of x, that means I have to integrate this function with respect to x. Now this one you can see that this is going to be using chain rule. Okay, so here what we're going to do is, first you have to ignore what is inside the function, only deal with the powers. So I'm going to write this as it is. Increase the power first, so the new power becomes 3. Divide by the new power. Okay, then in differentiation what we do is, when we are using the concept of chain rule in differentiation, we multiply by the derivative of what's inside the function. Okay, so we multiply by the derivative of what's inside the function, but for this one we are going to divide by the derivative of what's inside the function. So here, after I have increased the power and then divided by the new power, in the denominator I'm going to write down the derivative of what's inside the function. So what is inside the function? It is 2x minus 3. The derivative of this is 2. So I'm going to write 2 over here. So this is how you use chain rule in integration. As for the right hand side, here we just increase the power on x and then divide by the new power, and then we are going to write plus c. So let's simplify. 3 times 2 is going to be 6. So 6 and the 6 at the top, they cancel out. I would be left with 2x minus 3 whole cubed, and on this side I will be left with minus 3x squared plus c. So this is my function. Now at minus 1, sorry, at 1 comma minus 1, this means that minus 1 is equal to 2 times 1 minus 3 whole cubed minus 3 times 1 whole square plus c. So 2 times 1 is 2 and 2 minus 3 is minus 1. The cube of minus 1 will be minus 1. Okay. Now 3 times 1 minus 3 times 1, that would be minus 3 plus c. So therefore c is equal to minus 1. Now minus 1 minus 3 is minus 4. When this 4 goes to the other side, it becomes positive 4. So you get positive 3. Therefore, my f of x will be 2x minus 3 whole cubed minus 3x squared plus 3. This is going to be my final answer. Now, they're not different. They're exactly the same answers. However, this is the unexpanded form. Okay. And this one is the expanded form. You will still get, if you expand this and then you try to simplify it, you will still get the same thing. Okay, so that is the answer to this part of the question. All right, so let's move to question number 10. The equation of a curve is y equals 5 minus 2x to the power 3 upon 2 plus 5 for x is less than 5 upon 2. Okay, a point P is moving along the curve in such a way that the y coordinate of point P is decreasing at 5 units per second. Okay, y coordinate is decreasing at 5 units per second. What does this information tell you? This is also a question related to differentiation. This is what we call the application of chain rule. The question tells you that y is decreasing at a rate of 5 seconds, right? So at a rate of 5 units. So that means that dy dt will be minus 5. Okay. So this is what the question tells you. Then it says find the rate at which the x coordinate of point P is increasing when y equals to 32. So what you have to find is that what will be dx dt at y equals 32. Okay, that is what we need to find out. So first of all, let us try to get the expression for dx dt. Dy dx is equal to, now how do I usually write it is in this form, that we need to find dy dx but through a third variable. So first I'm going to write dy over here, then I'm going to write dx at the bottom. Okay, then what is the third variable? It is dt. So I'm going to write dt over here, so that if you try to expand it, okay, if you try to multiply it, these dt and dt will cancel out, you will get dy dx. Okay, all right. So now we know what is dy dt, which is minus 5. That is already given to you. We need to find dx dt. So that means you must have dy dx from somewhere else. So we know that the equation of the curve is y equals 5 minus 2x to the power 3 upon 2 plus 5. So from here, I'm going to find out what is dy dx. So again, this is a question related to chain rule. You're going to first multiply the power. So this is 3 upon 2 times 5 minus 2x. Then you subtract 1 from the power. So 3 upon 2 minus 1, that gives us half. And because this is a constant, this just becomes 0. Okay. Now, this is my dy dx. So let's see. The question has given you that uh, y is equal to 32, right? So if I want to find out that what is the value of x, what is the value of x when, sorry, my bad, I think forgot something. Uh, we haven't applied the chain rule, right? So this should also be, okay, let me do this again. We multiply the power, so 3 upon 2 multiplies over here, and then you subtract 1 from the power. So you will get 1 upon 2. Okay, the new power would be 1 upon 2 multiply by the derivative of what's inside the function. So that would be minus 2. The derivative of what's inside the bracket is minus 2, so we'll multiply it. As for this plus 5, this just becomes 0. Okay, so now you can see that this 2 and this 2 cancels out. So we would be left with minus 3, because here we have a minus 1 left, minus 3 times 5 minus 2x to the power of half. Okay, so there you go. That is your dy dx. Now we know that y is equal to 32. So what would be x at that point? Because if I want to find out the exact value of dy dx, then I need to have the value of x. So using the original equation, I'm going to write that 32 is equal to 5 minus 2x to the power 3 upon 2 plus 5. So first of all, subtract 5 to that side. So we have 32 minus 5 equals 5 minus 2x to the power 3 upon 2. Okay, now to understand what will be my next step, what if I change this and let's see, this is cubed, and 3 upon 2 basically means 3 times 1 upon 2. So 3 times 1 upon 2 would mean that I'm going to take the square root of this. So first I'm going to cube it, and then I'm going to square root it. So this becomes 27 equals 5 minus 2x whole cubed, and then under root. In order to find x, I have to first get rid of this square root, and then I have to get rid of this cube. In order to get rid of square root, I'm going to square both sides. Okay, square both sides. So here you have 27 square. Okay, square gets cancelled. So you'll be left with 5 minus 2x whole cubed. Now, in order to get rid of this, cube root both sides. So cube root of 27 square, and here will be left with 5 minus 2x. So what would be the answer to cube root of 27 square? That would be exactly 9 minus 5, 9 equals 5 minus 2x. 2x comes over here, 9 goes to the other side. Therefore, x will be minus 4 upon 2, which is equal to minus 2. Okay, so this is my x. Now I can plug in this value. Therefore, dy dx is equal to minus 3, and I'm going to plug in the value of x over here. So minus 3 times 5 minus 2 times minus 2 to the power of half. So this will be minus 3 times minus 2 times minus 2, that is 4, positive 4, and 5 plus 4 will be 9. So 9 to the power of half. So that would be minus 3 times 3, and that gives us minus 9, because 9 to the power half means square root of 9. Okay, so this is my dy dx at x is equal to at y equals to 32 and x is equal to minus 2. Now finally we'll go back to this equation that we formed earlier, this one. Dy dx, let me write this again. Dy dx is equal to dy dt times dt dx. This value is minus 9. Dy dt was already given to you at the beginning of the question, which is minus 5 times dt dx. Now, if I want to find because what I want to find out is dx dt, but let us first find out what is dt dx. I'm going to divide both sides by minus 5. So dt dx is equal to minus 9 over minus 5, which is 9 upon 5. Therefore, if I take reciprocal to get dx dt, then obviously the reciprocal of this will also take place. So this will be 5 upon 9. Okay, and that is your answer. All right, so dx dt is equal to 5 upon 9. That is the end of part A. Part B, the last part of this question and also the last question on this exam paper. Point A on the curve has y coordinate 32. Point B on the curve is such that the gradient of the curve at B is minus 3. So when y had 32, then we also found out that what was the x coordinate. It was minus 2, right? Over here, this one. So therefore, we know the coordinates of A. So A is minus 2 comma 32. Okay, that's the first thing. Then it also told you that the gradient of the curve at B is this. So we do not know what are the coordinates of B. So I'm just going to write xb and yb. But what I do know is that dy dx at B is equal to minus 3. Okay. Find the equation of the perpendicular bisector of AB. Okay. So if you want to find out what is the perpendicular bisector, so again, perpendicular bisector is a straight line equation, right? It's a linear equation, it's a linear graph. So you need the gradient of the perpendicular bisector of AB and you need one coordinate. Okay. So the coordinate that we usually take for perpendicular bisector is the midpoint of your line AB. Okay, so that would give us the coordinate, and now we need to find out what will be the gradient. So for the gradient of this, we need to know what is the gradient of the tangent. And for the gradient of tangent, that is already given to us actually, which is minus 3. So, but the problem is we need to find the coordinates of B first. Because how am I supposed to calculate the midpoint if I do not know what is B, right? So what I'm going to write down here is that dy dx is equal to minus 3 times 5 minus 2x. What was it? Because we already differentiated this right over here. This is my gradient function of the curve. So we have minus 3 times 5 minus 2x to the power of half. Okay, this is equal to minus 3 because this value is already given to you over here. Now what we can see from here is that minus 3 and minus 3 cancels out. So we are left with 5 minus 2x to the power of half equals to 1. Square both sides. So 5 minus 2x will still be 1. Now we can find out what is x. So 2x goes to the other side. So this becomes 5 minus 1 and x is equal to 4 upon 2, which is equal to 2. So this is the x coordinate of B. Now that I know what is the x coordinate, I can plug in this value into my original curves equation, which is y equals 5 minus 2x to the power 3 upon 2, 5 minus 2x to the power 3 upon 2 plus 5. Okay, except that instead of x, I'm going to write down 2. So let us work this out. 5 minus 2 times 2 is 4. So 5 minus 4 is just 1. 1 to the power 3 upon 2 will still be 1, and therefore y becomes 6. Okay, so therefore B is at 2 comma 6. Now that I have the coordinate of B, I have the coordinate of A, I can find the gradient. Okay, so gradient of AB will be, okay, let me first write down the coordinates again. A is minus 232, B is 2 6. So gradient of AB will be y2 minus y1, so that is 6 minus 32 over x2 minus x1, so that would be 2 minus minus 2. Okay, so you get minus 26 upon 4, which will be minus 13 over 2. Now This is the gradient of the line AB. So let's say this is A and this is B. So we have found the gradient of the line AB, and this should be something like this actually, because it's a negative gradient, should be something like this. So AB. Now, if I want to find the gradient of the perpendicular bisector, or the equation of the perpendicular bisector, first of all, so for that matter, this is going to be a perpendicular bisector. It crosses at 90 degree and it passes through the midpoint of AB. So in order to find this equation, we need to find two more things. Gradient of perpendicular to AB, that will be minus 1 upon gradient of AB. So that is minus 1 over minus 13 divided by 2, which gives us 2 upon 13. That is the gradient. Then we need to calculate the midpoint of AB. So midpoint of AB will be x1 plus x2 upon 2, comma y1 plus y2 upon 2. Okay, plug in the values. So minus 2 plus 2 over 2, comma 32 plus 6 over 2. So this becomes 0. As for this, we have 38 divided by 2, that would be 19. So 0, 19 is the midpoint. Now we can use the equation y minus y1 equals m times x minus x1, because now we have complete information. For the perpendicular bisector, we know its gradient, and we also know one coordinate through which that line passes, which is the midpoint. So y minus 19 is equal to 2 over 13 times x minus 0. Okay, have they specified any form? Yes, they have asked you to give in this form. Okay, so that means I'm going to multiply 13 to the other side. So y minus 19 times 13 is equal to 2x. 13y minus 19 times 13, that would be 247, equals to 2x. So therefore my final answer will be 2x, bring everything to the right hand side, minus 13y plus 247 is equal to 0. All right, so that is the end of our paper. So I hope that the concepts are clear, and obviously this is paper ones are usually lengthy and they train you a lot. So make sure that whenever you start attempting this paper, you always have your water with you and everything. Okay, and also your mind is fresh, because for this paper, okay, it's better to start this paper or solve this paper with a fresh mindset. Okay, so with that being said, this is the end of our video. I'll see you in the next video with another past paper. Till then, take care. Assalamu alaikum.